Hello, I am Varun Kumar, Assistant Professor in Department of Computer Science and Engineering College in Ajay Kumar Garg Engineering College, and today we are going to discuss Boolean algebra. What is the use of Boolean algebra? We are use Boolean algebra in circuit designing of whenever we are going to design the electronic circuit, we use the Boolean algebra to simplify the Boolean expression, and that particular simplified Boolean expression is used for the further designing of the circuit. So, first we discuss that Boolean algebra provide the operation and the rule for working with the set 0 and 1. We are taking the variable which possess the only two values, that is 0 and 1. It means that particular variable is in two state, either 0 or 1. So, this is used for electronic circuit and VLC design. We are going to focus on three basic operation, that is Boolean complement, Boolean sum, and third one is the Boolean product. Then what is Boolean complement? It means 0 complement is equal to 1 and 1's complement is equal to 0. And what is Boolean sum? It is also known as that is basic OR gate that has the following values, that 1 OR with 1, that result is 1, then 1 OR with 0, that result is 1, then 0 OR with 1, that result is 1, and 0 OR with 0, that result is 0. It means if all input is low, then output is low, otherwise high. Then Boolean product, it means 1 dot 1 become 1 and 1 dot 0 become 0, then 0 dot 1 become 0 and 0 dot 0 is equal to 0. It means if all input is high, then output is high, otherwise low. These are the Boolean function which is we consider that this is a set of 0 and 1, and variable x is called the Boolean variable if it assume value only from b. A function that b की power n is the degree of Boolean function. How many number of literals or variables are present in that particular function is called as degree. The Boolean function can be represented using expression made up from the variable and Boolean operation like complement and or etc. For example, we take the function that f which depend upon the two variable, that is x and y, and this is the table that from where x is 0 and y is 0, then function value is comes 0 and 1, 0 and 0, and different all possible values of x and y. What is the all possible value of x and y? There is two number of input variables, so total possibility is 2 की power 2, that become 4. So it means 0 0, 0 1, 1 0 and 1 1. For all pair of combination of input, we calculate the value of function which is depend upon x and y. So this values comes 0, 1, 0 and 0. So our possible solution is x bar y. It is written in sum of product. So we have discussed later this. Another solution, this is the function which is depend upon x, y and z, and all possible values comes from 0 0 0 0 1 to 1 1. Total combination is 2 की power 3, that become 8. For all possible inputs, we check the value of function. There is function, some values contain 1, some functions value contain 0. So we can calculate the possible solution. So there may be a multiple solution for the same function. So there is a simple method for deriving a Boolean expression for a function that defined by a table. This method is known as minterms and another method is known as maxterm. Or generally we are use that sum of product and product of sum. Consider this is a function. Then what we in SOP we consider only where is function is true. It means where function is getting value 1. So 1 is here, here and here. In SOP we design a particular solution for, we write that f, x, y and z that equal to how many times of 1's comes, that is 3 times, and we take first value, then plus, then second value, then plus, then third value. what is the first value where our function is true, that is x is equal to 0. So we consider in SOP 0 converted into lateral bar and 1 is represented by lateral. Like we calculate the value of x and y, that is 0 0 0. So we write that x bar, y bar and z bar, and second value is 0 0 1. It means x bar, y bar and z, and third value comes 1 0 0. It means x, y bar and z bar. So this is a Boolean expression for this particular function in SOP, sum of product. It is also known as min terms. So we can also write in summation, that is our function value is comes 1 on 000, which is decimal equivalent to 0. Then next one is comes 001, which is binary decimal equivalent 1. This is 100, which is decimal equivalent 4. So we convert this binary number into the decimal number, and we can write this particular expression into the summation, that is 014. It is also known as min terms. So question, how many different Boolean function of degree 1, let assume that x is possess the value 0 and 1. So what is the value of first function? Though for both input 0 and 1, it possess all zeros, and second function 0 1, then third function 1 0 and 1 1. Okay, so total possibility is 4 different function can be constructed by a single input Boolean function. If how many different Boolean function can be derived from degree 2? If it has the degree 2, it means there is some two variables like 0 0, 0 1, 1 0 and 1 1. It means it possesses 2 की power 2, that become 4. So there is total 4 different type of input which is comes in decimal, that is 0, 1, 2 and 3. So what is the first function, that is 0? It means for all input the output is all zeros. Then second function is 000 and 1 and so on up to the all 1. So how many total combinations are there? That is 2 की power 4. That become 16. So 16 different function can be derived from this. All tables are given like that. So we assume that if what will happen if degree n, if there is degree n, it means 2 की power n different type of combinations of input are can be derived. It means all zeros to all ones. It means 2 की power n. And how many functions can be derived? It means all zeros to all ones. It means 2 की power 2 of n. Okay, this is the formula for total different type of Boolean function can be derived from the n degree n. What is duality? If we have a Boolean expression like zeros and ones, for example, we have this particular expression and we want to write this dual function. So dot converted into plus and plus converted into dot, lateral converted into lateral and lateral ka bar converted into lateral ka bar. Okay, 0 converted into 1 and 1 converted into 0. So we can write the dual of this particular that this particular dot converted into plus, x converted into x, y converted into y, this plus converted into dot. Okay. Then what is the complement of this particular function? If we have any function and we want to complement this particular function, so in complement we using that 0 converted into 1, 1 converted into 0, lateral converted into lateral ka bar, then lateral ka bar converted into lateral, and dot converted into plus and plus converted into dot. Only dual and complement have only a single difference, that here lateral converted into lateral. It means there is no change of variable name. Or here the variable converted into variable bar. That is the difference. So what is the complement of this? That is x bar x converted into x bar, dot converted into plus, and plus converted into dot, and y converted into y bar and z bar. This is the complement of given function. This is the definition of Boolean algebra, that a Boolean algebra is a set of B with the two binary operation, that is OR and AND, elements 0 and 1, and a unary operation such that negation or NOT gate, which is known as complement of that particular variable, such as following properties. First is identity law. If we add 0 from any variable, that comes variable itself, that is known as identity law. Dominance law, these are the basic laws, okay, that is associative in nature, also commutative, then distributive law. Then logic gate, this is the symbolic representation of NOT gate, which if we give x and we get x dash, if we x complement of that particular input variable, that is known as NOT gate or inverter. This is the symbolic representation for OR gate, which x OR with y. Then this is the AND gate, which x dot y. So how many build a circuit that compute x dot y plus x bar y? We can use our basic gates, and we have to design this particular Boolean function, that x dot y, it means we take input as x and we select a gate, that is AND gate, and second input is y. So what we get? Output x dot y, and second function is x bar. Second function is x bar. So we write x bar, it means we use a NOT gate, input is x, then we get x bar, then second input is y, so then we connect this through the y, then it means x bar dot y. Okay, then now we want to perform this logical operation OR, so that we supply to the OR gate and we get the final function x and y. This is a simple method to implement our Boolean function into the circuit. This is the truth table of AND gate. As we told you that AND gate logic is, if all input is high, then output is high, otherwise low. Basically behind the AND gate there is a series of switches, and switches can be in two state, either switch is on or switch is off. If this particular certain condition, I mean we can say that the all switches are open, it means switches are off. If both switches are off, then is bulb is glow? No. So it means 0. If we connect this particular switch, then is it bulb is glow? Circuit is not complete, so bulb is not glow. If we connect this and open this, then is this bulb is glow? No. If we both switches are on, then output is on. It means the AND gate is the series of switches. And similarly, if we have three input variable A, B, C, and we find out the logic of AND gate, then if all input is high, then output is high, otherwise low. It means all input is, if all input is high, then output is high, otherwise low. So AND gate logic is, if all input is high, then output is high, otherwise low. This is the OR gate, simple OR gate, and if all input, we closely observe that this particular table, if all input is low, then output is low, otherwise high. So this is the switches combination of this particular OR gate. It is a parallel combination of switch, so we can compute easily. Then if both switches are off, then output is off, otherwise high. So, can we construct the table of 3 input variable that if all input is low, then output is low, otherwise high. So, we getting the logic. If all input is low, then output is low, otherwise high. This is the simple NOT gate. It means 0 to 1 and 1 to 0. This is the NOT gate. This is the shunt connection of this. If this is a bulb, then this is a circuit. If we open the circuit, if we open the switch, then current flow from this path and bulb is glow. If A is equal to 0, it means Y is equal to 1, bulb is glow. If we connect this particular switch, then what will happen? Current always follow the shortest path. So, all current follow this particular path. So, minute current is going into the bulb. So, bulb is not glow. If A is equal to 1, then Y is equal to 0. So, this type of switching circuit used for the NOT gate. Similarly, NAND gate is AND gate plus NOT gate become NAND gate. So, what is the logic of AND gate? If all input is high, then output is high. So, NAND gate, after that we perform the NOT operation. NOT operation which means if all input is high, then output is low, otherwise high. This is the circuit. Then this is the table. We can check this. If all input is high, then output is low, otherwise high. So, this is the logic. If all input is high, then output is low. So, you can compute yourself that this is the table of NOR gate. If all input is low, then output is high, otherwise low. This is the circuit and this is the table. Then if all input is low, then output is high, otherwise low. This is the NOR gate logic. If all input is low, then output is high, otherwise low. This is the XOR gate, which is stand for exclusive OR gate, XOR gate, XOR gate. This type of representation we are using for the XOR gate, and this logic is we calculate the number of ones counted. If this number of ones are odd, then output is high, otherwise low. If number of high input is odd, then output is high, otherwise low. Then can we compute this? We calculate how many number of ones are 0. 0 is a even number, so it comes 0. Then how many numbers of ones? That is 1. Then output is 1. Then next number of ones 1. Then output is 1. Number of 1 is 2. So it is even. So comes 0. Then again 1. Then 0. Then 0. Then number of ones is 3. 3 means odd number. Odd number means 1. Okay. We get the logic. This is the symbolic representation for XOR gate. Then XNOR gate again XOR plus NOT gate become XNOR gate. Just reverse the logic. If number of high input is even, then output is high, otherwise low. So, this is the table for XNOR gate. Then basic gates AND, OR and NOT are the basic gate because these gates are constructed by combination of switches in series, parallel or shunt connection with the load. NAND and NOR are the universal gate. Universal gate are those gates by which we can implement all the basic gate. So, NAND is a basic gate. Or what is the logic of NAND gate? NAND gate is AND bar. It means if we connect both input to the A, then what comes here? A. What comes here? A. And what comes here? A. Then A dot A ka bar. That become A bar. It behave like a NOT gate. If we connect A and B, NAND gate output is AB dash, then again configuration of NOT gate, it will become again AB. It behave like a AND gate. and this is for OR gate. We input A, we get A dash, we get input B, then we get B dash, and we supply to the NAND gate, that becomes A plus B. It means NAND gate work as a AND gate, OR gate and NOT gate. So we can say that NAND gate is also a, usually we have implement that NOR gate. Then NOR gate, if we short the both input in NOR gate, so we get a NOT gate, then NOR, then plus NOR plus AND, that become again a OR gate. And how we convert this into the AND gate, that is NOR gate, it means A dash, then B dash, again a NOR gate, which is comes A and B, which is behave like a AND gate. This is for OR gate, so it means NOR gate is also a universal gate. So what will happen if any gate pin is broken? AND gate, what is the logic of AND gate? We assume that there is 5 pin in the AND gate, that output is A dot B dot C dot E. Let assume that pin E is break. Whatever we are supplied the voltage to the E, but we are not getting to the gate. So what is the value of E? E is equal to 0, and if any input in AND gate is 0, result is 0. So output is always low. It means AND gate is not work properly. And what will happen if any gate pin is broken? Then we consider that this is a OR gate. Then what is the logic of OR gate? A plus B plus C plus D plus E. If we assume that E pin is broken, then it means value of E is equal to 0. If we add any Boolean expression x with 0, we getting output x. So it means what is the output? That is A plus B plus C plus D. It behave like a n minus 1 OR gate. Okay. Then we check for another NAND gate. NAND gate is just and or put E is equal to 0. Then what will happen? This particular value is again 0. Then G complement become 1. Output is always high. It means NAND gate is not work properly. And what about NOR gate? Again substitute E is equal to 0. It means output is A plus B plus C plus D bar. It means it behave like a n minus 1 input NOR gate. And what will happen if pin get connected with VCC? It means that particular pin is sorted with VCC. It means Boolean function high. If we put E is equal to 1, it means we get A dot B dot C dot D. It behave like a n minus 1 input AND gate, and similarly same operation for the NAND gate. And what will happen for OR gate? If we put E is equal to 1, A plus B plus C plus D, that plus 1, that some expression x plus 1 become 1. It means output is always high. It means OR gate is not work properly, so NOR gate is also not work properly. So we conclude this, we have to calculate this NAND gate, and similarly for NOR gate, it is not work properly. We check that if our input variable is A and B and our function is this A and B, that 0 0 and 1 1, what we can write in SOP? We can say that in SOP, that particular variable, that is x, 0 is converted into x ka bar and 1 converted into x, यानी कि literal. 0 converted into literal ka bar and 1 converted into literal. So what is the value of A and B? A value just 0 and B also 0. So it write as A dash dot B dash, sum of products. Then next value, what is the value of A? A value is 0. So here comes A bar. Then what is the value of B? B comes that B. Then what is the value of 1? That is A. Then 0, that is B bar, A dot B bar, and what is the next value, that is 1 and 1, so it is write as A dot B. Okay, then same expression we can denote in product of sum, that is POS, product of sum, but here we use that 0 converted into literal and 1 converted into literal bar. That, so what comes 0 0, it means literal, it means A plus B, and then again A plus B bar, then A bar plus B, and similarly A bar plus B bar. Okay, then so we can write our function into SOP and POS as well as both. Like in SOP, we can write how many number of ones, that ones comes here and here, so we write that is sum of products. These are the products and we provide the sum of products, how many number of ones comes in our function. And in POS, we computation of zeros, how many number of times zeros comes, 0 comes that place and that place. So we write in POS that is A plus B and A plus B bar. It means product of sums. These are the sums and we have to connect these two values by product of sum. So this is the particular expression for 3 variables. We write all that 0 0 0 A bar, B bar, C bar, and similarly up to ABC, and here 0 converted into literal, B also, then C, then what is 1 1 1, that is A bar plus B bar and C bar. So our objective is to define this particular function in SOP and POS. For SOP we compute only 1. So we have only 3 terms in SOP and remaining 5 terms in POS. So in SOP we can write that first one comes at A bar, B bar and C bar. Okay, then second one comes A bar, BC, and last one comes AB and C bar. So these 3 values are in sum. So that's why it is called as sum of products. And same function we can denote in POS. So how many times 0 comes? 1, 2, 3, 4 and 5. So we have 5 terms in our POS. So same function can be represented that 0 comes at A plus B plus C bar, and next 0 comes A, B bar, C, that in product. Then next, and then next. So how many terms? There is 5 terms because of function contain 5 zeros. So our expression contain 5 terms. All terms are in product. So that's why it is called as product of sum. If we have a Boolean function like this 1, 0, 0 and 0, so can we represent this into SOP? So SOP count only 1. So it means in SOP our function which is depend upon A and B, that becomes A bar and B bar. Okay. Or in POS, same function we can write in A and B. There how many times are zeros? That is 3 times. So 3 times all 3 values are in product, that is A plus B bar, then dot with A bar plus B and dot with A bar plus B bar. So same expression we can write in SOP and POS. This is the half adder, that is A and B. These are the sum. 0 plus 0, that is 0, 0 plus 1 become 1, 1 plus 0 become 1, 1 plus 1 that become 2, and quotient value remainder is 0 and quotient value is 1. So it means carry is 1. So we can write the same in SOP and POS. So we have to compute that how many number of ones and zeros. If we select zeros, so it means our terms comes 3 times. And if we count this particular one, so we have only a single terms. So we have to compute this particular carry in SOP. And what about the sum? Sum contain two zeros and two ones. So we can convert this particular function into SOP or POS. Same number of variables are used and same number of terms are used. So this is the circuit diagram of this particular this. The sum ka expression is A XOR B because this is the XOR gate. That values is A bar B plus A B bar. And what about the carry? Multiplication of two, both, it means A dot B. Similarly, this is the full adder circuit. We sum up the all three digits 0, 0, 0, 0, carry 0, then 1, then 1, then 1, then 1, 1 plus 1 become 2, 2 become yani ki 0, carry 1, then again 1, 0, then 2, 0, 0, then 3, 3 divided by 2, remainder is 1, and carry is 1. So our Boolean expression is this. Then sum contain 4 ones. The same position we have write this is equal to the 4 position, and this expression is converted into A XOR B XOR C. And what about the carry? Carry again also have the 4 ones. So we write the expression, same expression as it is. And we have to simplify this particular, then we getting this result that AB plus BC plus CA, and we have to implement this particular by using our basic gate and all universal gates. Thank you.